Hello, Mr. Pepperell here, and in this little video I'm going to be talking to you about electrical resistance and Ohm's law. So, like we've mentioned previously, electrical resistance is the opposition to the flow of current that we measure in that funny little symbol there, ohms. Okay. Now, just to sort of remind ourselves, an electrical current flows when electrons move through a conductor like a piece of wire. Now, these moving electrons can collide as they're going through the wire. They try and moving down through here, but they actually collide with the wire atoms, and this makes it more difficult for them to flow. So a resistor is anything that causes this opposition in a circuit. Okay. So what we can do is we can use a graph of potential difference versus current to show how the current through one of these resistors will vary with the potential difference across it. And if we plot it, it will look something like that. Okay, so we can see from this graph that as the potential difference, or the voltage here, increases, the current increases as well. So we get this line being plotted by the increase in voltage and the increase in current. Okay, now if we keep this resistor at a constant temperature, we will find that the current potential difference graph will give us a straight line passing right through the origin there. Okay, so what does this straight line mean? Well, it shows us that current is directly proportional to the potential difference across the resistor. That's what a straight line shows us if it passes through the origin. Okay, so the fact that this graph is directly proportional is actually Ohm's law. Okay, and Ohm's law states that the current through a resistor at a constant temperature is directly proportional to the potential difference across the resistor. Okay, that's exactly what that graph shows us there. Okay, as the current goes up, it goes up with the potential difference increasing as well. Okay, one of the important things here is the fact that it's at a constant temperature as well, and we'll talk about that a little bit later on. Okay, so any component that actually obeys this law, where you see this graph being plotted, if you measure the potential difference in the current, is what we call an ohmic conductor. Okay, so any component that obeys the law is called an ohmic conductor. However, not all components do obey it, and we'll look at those in a later video. Okay, so that is electrical resistance and Ohm's law. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell, and I'll get back to you ASAP, and I'll see you next time.